And welcome guys to my channel Quantum Analysis. Once again I am back with another video, and today we will start speed and velocity and continue the chapter M.O.D motion in one dimension. I hope that you guys saw the last video which I made on distance and displacement part. Okay, so let us begin with the speed and velocity. Okay, so what is the speed? So the speed of a body is a rate of change of distance with time. Numerically, it is a distance traveled by the body in 1 second. It is a scalar quantity. It is generally represented by the letter small u or v. If a body travels a distance s in time t, then the speed v is speed v equal to distance s by time t. So I will give you the notes in the copy. Okay, so now this is definition of speed. It's okay. The speed of a body is rate of change of distance with time. Numerically is the distance traveled by the body in 1 second. It is scalar quantity. Is generally represented by the letter small u or small v. Now if a body travels a distance capital S in time small t, then its the speed small v is speed v equal to distance s by time t. So speed equal to distance by time. We will do some numericals on the formula based on it. We give it a star mark. It comes in the exam. Okay, now let us move to the unit of speed. Means what is speed? What is the unit of speed? So it is interrelated with distance and time. So okay, so now you guys think for a second that what can the speed of, what can be the unit of speed? So if speed is interrelated with distance by time, then what is the speed unit of distance? Unit of distance is meter. SI unit of time is second. So what can be the unit of speed? It can be meter per second. Okay, so now you guys should understand the SI unit of speed is meter per second, and that of Celsius unit of speed is centimeter per second. Okay, so this is a unit of speed. Unit of speed is distance as meter, SI unit of speed, distance is meter, and time small t is second. So the speed equal to meter by second, and generally in the x1 is we learn that meter per second minus 1 or meter per second. Now usually in the boards we should write meter second minus 1. This is the right form, though it is also the right form, but it's not used commonly. It is used, so you guys should write meter per second minus 1. Okay, so let us move to the uniform speed, non-uniform or variable speed, instantaneous speed, and later on we'll study more about it. Okay, so now what is the uniform speed? So uniform speed is nothing but a body is said to be moving with uniform speed if it covers equal distance in equal interval of time throughout its motion. Means you guys should understand that if a body is moving 5 seconds, it will cover a distance 5 meter, and as opposite to it is variable speed or non-uniform speed. If a body is said to be moving with non-uniform or variable speed if it covers unequal distance in equal interval of time. Means unequal distance means body is moving, means body is traveling a distance of 6 meter in a time 4 seconds. So it is unequal distance in equal interval of time. Okay, so now we will move to the examples of uniform speed and example of non-uniform or variable speed. Okay, so example of uniform speed is the motion of a ball on a frictionless plane surface is with a uniform speed. Motion of ball in a frictionless surface is with a uniform speed. I will give a diagram of it, don't worry. Knowing the uniform speed of the body, we can calculate the distance moved by the body in a certain time of interval of time. If a body moves with a uniform speed small v, the distance traveled by it is in time small t is given as f is equal to small v into small t. Okay, so from the relation speed is equal to distance by time, you will calculate distance equal to speed into time. Okay, so basically this is the concept of uniform speed. A body is said to be moving with a uniform speed if it covers equal distance in an equal interval of time. For example, the motion of a ball in a frictionless plane surface is moving with a uniform speed. So basically this is a diagram of it. It's a frictionless plane surface with the ball, and this dotted line shows the distance the ball might have covered is 5 meter, and in such time, in time t, let it be 5 seconds. So we can understand equal distance in equal interval of time means the body is moving at a uniform speed in a frictionless plane surface. So basically, for understanding more about uniform speed, let us move to one other thing, and what it is, let me show you. Okay, so knowing the uniform speed of the body, we can calculate a distance moved in a certain interval of time, let it be small t. If a body moves with a uniform speed small v, the distance traveled in distance s in time is small t is s is equal to vt. And how it came I will show you just now. Wait. So here's the derivation of s is equal to vt. Generally it doesn't come in the exam, but for your understanding I have derived it. When you know speed is equal to distance by time, then from cross multiplication speed into time equal to distance, then small v into small t equal to distance means capital S and s equal to vt. So it is the clear understanding of uniform speed. Let us move to variable or non-uniform speed. Okay, so as I've told you earlier too, that what is a uniform or what is a non-uniform or variable speed. A body is said to be moving with non-uniform or variable speed if it covers unequal distance in equal interval of time. For example, let us take a body moving with a certain speed and moving a certain distance. Let the certain distance be 5 meters and moving with certain time. Let the certain time be 4 seconds. So it is clear from here that the distance traveled is not equal to the equal time which the body has taken earlier for the uniform speed. So it is known as non-uniform or variable speed. I hope that you guys understand. One other example of non-uniform variable speed is the motion of a ball on a rough surface, the motion of a car in a crowded street, the motion of a vehicle leaving or approaching the destination are with non-uniform speed. So the motion of a ball on a rough surface, how we will know something from this, that how non-uniform speed or variable speed is acting on it. So if a ball moves on a plane surface, it will go smoothly, but it will go in a rough surface, it will face some difficulty, some problem to go with the full speed. So it will cover less distance in equal interval of time. Now if a body is moving in a crowded street, then if the street is not crowded, then the body will move smoothly. But if the city is crowded, then we will get to face some problems, so we will not reach the destination on time. So I hope that you guys understand the motion of a car in a crowded street. And on the same thing, the motion of vehicle leaving or approaching a destination is with the same explanation. So I think you guys understand that why a vehicle is not able to approach the destination in a certain time, because there is so much of crowded. As you guys also travel in buses, cars and train, you guys see that if there is a crowded or if there is a problem, the train goes slow, the train must not reach the station on time. So from here you can conclude that it is an example of non-uniform or variable speed. In case of bodies moving with non-uniform speed, we specify the instantaneous speed and the average speed. Now let us move to the instantaneous speed. Okay, so now what is instantaneous speed? When the speed of a body keeps on changing, means it is not fixed, keeps on changing. Its speed at any instant is measured by finding a ratio of the distance traveled in a very short time interval to a time interval. This speed is called the instantaneous speed. Thus, instantaneous speed derives the distance traveled in a very short time interval divided by a time interval. Okay, the instantaneous speed can be measured from the speedometer of a vehicle. It means that the speedometer of a vehicle measures the instantaneous speed. Now we'll explain how it works and what is instantaneous speed. The thing which I have told you just now was the actual definition of instantaneous speed, but now I will explain you what is instantaneous speed and how it works on us. So for understanding the concept of instantaneous speed, I have drawn a diagram for you and I've given a full explanation of it. So here is instantaneous speed. So what is instantaneous speed? When the speed of a body keeps on changing, its speed at any instant is measured by the find the ratio of distance traveled in a short time interval to a time interval. This speed is known as instantaneous speed. It is measured by the speedometer of a vehicle. So this question comes in exam mostly, that how can we measure the instantaneous speed? So we can measure instantaneous speed with a speedometer of a vehicle, and I have given a small diagram. I hope that you guys can see the diagram. That here is a man who is moving a certain distance with a certain time, but it is not equal with each. So when a guy is moving, let it be A to B, the distance is covered is not known to us, but the speed he's traveling with is 5 seconds. Then again from B to C he's traveling with a speed of 2 meters per second. Then again from C to D he's traveling with a speed of 10 meters per second. Then again from D to E he's traveling with a speed of 8 meter per second. So from here we can conclude that he is moving with the instantaneous speed, because we all know that when the speed of a body keeps on changing, it is speed at any instant is measured by the finding the ratio of distance traveled in a short time interval to time interval. This speed is known as instantaneous speed. So basically it is a small diagram that represents the instantaneous speed, though it doesn't come to exam, but for your understanding I have given it. So let us move to the average speed. Now let us move to the average speed. Then what is the average speed? The first question arises here. The ratio of the total distance traveled by the body to the total time of the journey is called this average speed. Thus average speed gives the derivation of total distance traveled by total time taken. Means the body is moving from A to B, then again from B to A. The total distance traveled from the body is A to B is 10 meter, and from B to A is again 10 meter. The total distance traveled is 20 meter, and the time he has taken from A to B is 5 seconds, and again from B to A is 5 seconds, and the total time is taken is 10 seconds. So average speed becomes 20 by 10 equal to 2. So here is average speed. Average speed became 2 meter per second. So from here we will solve some numericals of average speed after the chapter is complete. Now in case of a body moving with a uniform speed, the instantaneous speed and the average speed are equal, same as the uniform speed. Okay, so here is the full understanding of the concept of average speed. Now the total part of the speed is covered. Okay, so first I have given the definition of speed, what quantity it is, what is the formula of it, I have told you, and now I have already completed the uniform speed, non-uniform variable speed, instantaneous speed, and average speed is also completed. Now we will move to the velocity part, and we will do the uniform velocity, non-uniform variable velocity, instantaneous velocity, and average velocity. Then we will move to the difference of it. Now let us start with velocity. So what is a velocity? The velocity of a body is a distance traveled per second by the body in a specific direction. Thus, the rate of change of displacement of a body with time is called the velocity. It is numerically equal to the displacement of a body in 1 second. It is a vector quantity that it is represented by the symbol arrow small u or arrow small v. For velocity, both its magnitude and direction must be specified. Two bodies are said to be moving with the same velocity if both of them move with the same speed in the same direction. On the other hand, if two bodies move with the same speed but in different direction or with different speed in the same direction, they are said to be moving with different velocities. So what can be the unit of velocity? So the unit of velocity is same as the unit of speed. The SI unit of velocity is meter per second, and our serious unit of velocity is centimeter per second. Now let us move to the uniform velocity. Okay, so this is the velocity part which I have taught you, and this is the uniform velocity part, and this is a new part we will start from now. So if a body travel equal distance in a particular direction in equal interval of time, it is called uniform velocity. For example, raindrop falling on a surface with uniform velocity. A body once started on a frictionless surface moves with uniform velocity. Okay, so this is a unit of uniform velocity. If a body moving with uniform velocity, arrow small v, has displacement in a time interval small t, then my definition, arrow small v equal to arrow small s by t, which is displacement. Okay, so now let us move to the non-uniform variable velocity. If a body is moving with unequal distance in a particular direction in equal interval of time, the body is said to be moving with non-uniform velocity. For example, motion of a freely falling body is with variable velocity because although in the direction of motion does not change, but the speed continuously increases or changes. Now let us move to the main objective of the chapter, the circular path motion. I will give you 5 or 6 questions from this circular path motion. Okay, so from here we can know that what is the first point of difference between uniform speed and non-uniform and uniform velocity is that in the uniform speed body travels equal distance in equal interval of time, but there is no particular direction. But here a particular direction is coming, a specified direction is coming. It is because it is with a displacement. So now let us move to circular path motion. Okay, so here's our first question. Here the motion of a body in a circular path is even with a uniform speed is with a variable velocity. Explain why. So it comes of 2 marks in the board's exam. and normally in the annual exams of every school. It is a very important question of the circular path motion. So let us move to the answer. Because in a circular path, the direction of a body continuously changes with time. In fact, its velocity changes at a uniform rate. At any instant, its velocity is along the tangent to a circular path at that point. Now, this is the answer of this question. You have to remember this answer, because if you will write this answer in the exam, 2 marks will come in your book. Okay, so now let's move to the second question. What does small v in the figure denotes? Here small v represents direction of velocity at different points A, B, C and D of the circular path. So these two questions mostly come from circular path motion, and you have been asked sometime that the motion of a body in a circular path is how. So the motion of body in a circular path is with a uniform speed but with a variable velocity. So this can be third question too, but if you will read the book clearly, you will get the answer of all these questions. Now let us move to instantaneous velocity and average velocity. Okay, so now what is the instantaneous velocity? So for a body moving with a variable velocity, the velocity of a body at any instant is called its instantaneous velocity. It is measured by finding the ratio of the distance traveled in a sufficiently small time interval to the time interval. It is important to have time interval small enough so that the direction of a motion does not change during this interval. I will give a small example of it, and this is a very important example. Now, okay, so we are almost at the end of our chapter. What is instantaneous velocity? For a moving body with a variable velocity, the velocity of a body along the body at any instant is called instantaneous velocity. How it is measured? The first question comes here. It is measured by finding the ratio of the distance traveled in a sufficiently small time interval to a time interval. Now let us move to the average velocity. If the velocity of a body in a particular direction changes with time, the ratio of the displacement traveled to the time taken in the entire journey is called the average velocity. Average velocity equal to displacement by total time taken. Now I am giving you some extra. What is terminal velocity? It is not included in our chapter, though I am also giving it. So listen me very quickly. Initially, as the raindrop starts falling, initially as the raindrop starts falling, first the velocity increases due to the force of gravity. Okay, the velocity of a body increases the force of gravity as the raindrop starts falling initially. But very soon, due to viscosity or friction and upthrust of air, we all know that when a body goes up or goes down, some force acts on the body. It is the viscosity of force, friction force, or the upthrust of the body. We will study it in the upthrust chapter. Upthrust in fluid and atmospheric pressure. What is upthrust and what is weight? The viscous force and the upthrust balances the force of gravity on the raindrop, with the result that the net force of the drop becomes zero. We all know if a two force balances a body, the net force on the body becomes zero. This is a very important question, comes in MCQ most of the time. Then the drop falls down with a uniform velocity. Okay, so whenever drops fall down with a uniform velocity, it will have some velocity or the velocity will be zero. So the above velocity part is known as terminal velocity. So once again I am repeating myself. Initially, as the raindrop starts falling, first its velocity increases with the force of gravity, but very soon, due to viscosity or friction and the upthrust of air, the viscous force and the upthrust balances the force of gravity on the raindrop, with the result that the net force on the drop becomes zero. Then the drop falls down with a uniform velocity called the terminal velocity. So our chapter is almost complete. Now I will give you the difference between speed and velocity. Then we will move the next step with acceleration and retardation. Okay, so this much is the difference between speed and velocity. The distance traveled per second by a moving object is called its speed. The distance traveled per second by a moving object in a particular direction is called its velocity. It is a scalar quantity, it is a vector quantity. Speed is always positive depending on the concentration of direction. Velocity can be positive or negative depending upon the direction of motion. After one round in a circular path, the average speed is 0. After completing each round in a circular path, the average velocity is 0. So our chapter is almost complete. From next day I will complete the whole chapter because only a less part is left. You can see over here acceleration and retardation, and this much portion is left. Now after that we will move to the exercise part, and I will do all of the exercise over here. Okay, don't worry about it. So for today this is much, and we'll meet in the next class. Till then, tata, bye bye. Jai Hind, Jai Bharat.